Welcome, James.
Thank you very
Thank you
much.
for joining us this evening, and over to you.
And thank you very much, everybody, for joining us on this Evening With session. My intention is to cover aspects of 3D printing. I have limited experience in this area, but I've learned a lot. And I think as a relative newcomer, some of the things I've learned perhaps will be useful to you, because I didn't find them obvious when I first started. So what I'm going to do is I'm going to share my presentation first of all. Okay, I hope you can all see the first slide of the presentation.
Yeah.
And this is where I hope that the keys actually will allow me to move on. Yes, okay. So first of all, let's have a quick look at the various types of 3D printing that currently exist. The first word is one I've struggled to say properly: stereolithography. Try saying that after you've had a beer or two. Stereolithography is the kind of system that the new resin printers that have become quite inexpensive, that's what they use. You've also got selective laser sintering, fused deposition modeling. Now, FDM is the other most common type that you can buy at inexpensively. And then the other ones are going into all sorts of expensive mechanisms where you're effectively melting metals into shapes from a bath of metal particles, etc. Lots of ways of doing things, but there's two in particular that we use. Effectively, there's these two: the filament one, FDM, filament deposition modeling, and that uses a kind of plastic wire which is melted in a head and deposited down onto the model, and the model is built up in layers. The other one, SLA, resin, this is the typical resin cured using ultraviolet light mechanism. And it's this one that I've been using more recently. I have used both, but it's the resin one that I'm using more recently, and I'll come on to show you why. So FDM, the cheaper mechanism, very good for scenic parts, and I found it very good for coach roofs. Most of this type do produce a fairly rough surface finish. The layers are fairly large in comparison to other methods. So where surface finish isn't very important, and I would argue for scenic parts that's usually the case, this is a perfectly adequate way of doing things. It's also far less messy than the other one. And here are some examples of things that I've done. Coach seats are a perfect example of using this technology, where actually the surface finish, being slightly rough, can look like cloth. So you can get the impression of, particularly when it's painted, of something that looks much more like a cloth. It's not smooth in the same way as a wooden bench seat would be smooth. So that's quite a nice use of that particular technology. And for the same reason, roofs. This is a Southern Railway standard van that I wanted to build. This is completely scratch built. The roof is a 3D print done on a FDM printer. And once again, because of the canvas nature of a roof, the rough surface that you get is, again, quite advantageous. And you can see in the enlarged picture the sort of roughness of that surface. And it just gives it that little bit of texture that, once again, you wouldn't get on a resin printer. Using the resin type of printer, where the resin is cured with ultraviolet light, you do get extremely good details and extremely good accuracy. And I've got an example here of this one here, where you can actually read Bow Road Works, NLR, North London Railway, I think. Yes, I'm sure it is. I did this for a friend, and the diameter of that ring that you see is 4 millimeters. So those letters are less than a millimeter in height, and yet you can see all the detail. It's quite extraordinary. The parts on the right-hand side that you see alongside a ruler, these are it's just examples of supports actually attached to a very, very tiny valve that is going to go on a weed killing train for a friend of mine who's doing a 4 millimeter weed killing train. So these are going to sit, these are the valves that sit and allow the weed killing liquid to be pumped out from the sides of the tenders. The disadvantage with the resin method of 3D printing, it's messy and it's slow. So even the small tiny parts on the right hand side took an hour. And they are, as you can see, literally 10 millimeters long and not very tall. And half of that time is building the supports. So further examples, this is Ian Kirk kit of the Great Western Siphon H that I built. And once again, the roof was produced on a filament printer, but in 2 halves. No, I don't have a printer that's big enough to print the whole thing in one go. That's a pretty long vehicle. But I printed it in 2 halves. The halves matched extremely well. I glued them together, filled in the gap, sanded it down, and you'd never know. Another variant of the van that I built was this mobile welding unit. And here we can see various 3D printed parts. The roof, once again, is something that I produced on a filament printer and again sanded it down to give it a slightly less rough surface than it started with. But in addition, the buffer bodies here, buffer bodies were produced on a resin printer. The axle boxes I drew up and did them on a resin printer as well. And this along here, hope you can see where my mouse is pointing. The brake lever guide was also made on the same type of printer with all the pinholes all the way down the front of it. And the pinholes actually came out. And that's one of the major advantages of the resin printer. The resolution is extraordinary. It's extremely good. So all in all, on this particular vehicle, there are 15 separate 3D printed parts. The rest of the vehicle was made on a laser cutter. It's all cut out of a type of plastic that includes acrylic. It's a plastic called Romark, and all of the strapping, the sides, ends, underframe, etc. all produced on a laser cutter. So entirely scratch built with the aid of a computer. This is a vehicle that I've always wanted to build. And once again, this is about 90% made on a 3D printer. Once again, a filament type, actually, in this case. This was actually done quite a few years ago when I was still at work, and the company I was working at had a filament printer, a very large industrial machine. And I said, any chance I could make some of my railway wagons on it, please? And yeah, they said, yeah, go ahead if we're not using it. So the entire sides, W-irons, axle box, and the cross member, the buffer beam, and the cross members behind were all made. So there's effectively two drawings here, one of the entire side and one of the end. Made two of each, they clip together, and then the rest of the parts are made from brass sections with commercial buffers.
James,
yes,
sorry, that's the one you had at Kettering 2020, wasn't it? I think that's when I first saw that.
yes, it is.
Yeah. So 3 years in the making almost.
Well,
Well, two and a bit.
yeah, I made this a long time ago, actually.
Yeah.
Even longer than that, probably 6 years ago.
Really?
Yeah, because it's that long since I last went to work, Ian.
Right. Oh, right. Okay. Show off. Sorry, carry on.
Yes. So yeah, very successful. The filament printed sides are remarkably rigid. So it's never warped at all in its since it's been made. And then another thing that I did with the 3D printer, I bought many years ago. I'd always wanted a Q-class loco, and I bought a DJB kit. Made most of the parts quite successfully. Tender went together really well. Cab was fine. Smoke box went together nicely. But I could not get the boiler to look right. No matter what I did, it just was wrong. And it turned out, when I looked at it really carefully, that it had been designed upside down. The Q-class, as you know, there's one preserved on the Bluebell Railway. The Q-class has a tapered boiler. The underside of the boiler is parallel with the footplate, and the top of the boiler, naturally, is the one that tapers. So it tapers down from the firebox to the smoke box. But DJB had made it the other way around. The parallel bit was on top and the tapered bit was on the bottom. There was nothing I was going to be able to do with the brass. So you can't turn it upside down because the ends aren't then at right angles in the right places. So I ended up, when the technology was around, I ended up 3D printing a new boiler. And because I'd made a bit of a mess of the firebox, I couldn't get it square. I 3D printed a new firebox as well. And those two parts allowed me to complete the engine. I mean, the engine had sat in a box for the best part of 20 years, with me wondering how to get it to be finished. So there's some examples of things that I've made on the railway side. On the scenic side, I've recently been populating a fish shed for my layout, and a sort of general goods shed. So I need barrels, I need boxes, I need milk churns of different types. All of these have been recently drawn on 3D, on Fusion 360, which is my current 3D CAD program, which is free, and then made on the resin printer. And if you look at things like the handle is an integral part of the milk churn. The section of that handle is 0.5 millimeter. So you can make some pretty tiny bits on a resin printer very successfully. And you can see on the left-hand one, on the you can see the bull lines on that milk churn, but they're so small, really, you're not going to see. I make my parts, each layer, I'll come on to layers and explain them a bit more later on, but each layer is 0.05 of a millimeter. So you've got 20 layers per millimeter. So you can imagine that at that resolution, you're not going to see much in the way of surface degradation. So one of the important things when you're designing your parts is to think about how the printing process actually works. And that's what mostly the subject of this talk is going to be. How do you actually how does the resin printer work? Why do you do things in a particular way? And are there some issues with designing the parts that will make the parts come out better when you actually make them? So if you're going to design for resin printing, firstly, avoid hollows. You can have a hollow with a filament machine, that doesn't seem to matter. But the way the resin ones work is that resin can get trapped inside the hollows. So if you've got a hollow part, the resin will not flow out of it unless you provide some form of exit for the resin. Minimize overhangs, because overhangs need supporting. You can't magically create a lump. Again, it'll become obvious when we look at a part. You can't produce something that just hangs out over the side of a part. So if you take the milk churn, for example, the lid sticks out over the tapered part of the milk churn. So that's what I mean by an overhang. And the other thing to consider is a minimum thickness of any of your parts. And I would say 0.5 millimeter is doable. You can do less, but you're going to run into issues if you do. And some of this is all about trial and error. And oh boy, I've had a lot of errors. Okay, so where do you start? Firstly, you need to design your parts. So looking at CAD software that's available, Fusion 360, I have moved on to. I used to use SolidWorks, but I had a commercial license for that when I was running my own business. But at £5,000, well, it was back in 2008, it was £5,000. That's not really affordable for hobbyists. Fusion 360, on the other hand, if you are a hobbyist, you can use it for nothing. And TurboCAD is an alternative that some of my friends use. I'm sure there are others, but I have no experience of them at all. So Fusion 360, I know we've had a number of sessions on Zoom in the Gaujo Guild about using Fusion 360. And they've been extremely useful and very informative. I hope some of you have attended those sessions. They've changed some of the attributes of the program, and you're now limited to 10 editable drawings, but it doesn't appear that there's any particular limit on the number of drawings you can have read-only. So you can simply switch drawings between read-only status and editable status, and it seems to work fine. It's easy to use. I find it easy to use. There's lots of help online, lots of videos, a lot of other people use it and post useful information. And you can also export drawings and send those to other people. And of course, you can send drawings then to agencies as well, should you wish to. People like Shapeways, if you don't have a printer of your own. So the first step in Fusion 360 is to prepare your drawing for printing. The first thing you have to do is to create something called an STL. That's a stereo lithography file. So the steps are: draw the component, go to the Utilities menu, select Make, 3D Print, which brings up a box, as you can see on the right-hand side. And then down on the options, on the output, it says Send to 3D Print Utility, which by default will be ticked. And you want to untick that because you don't have one of those. And then press OK when you're ready. And I'll quickly take you through that step in Fusion. Okay. Can you all see the milk churn?
Yeah. James, just before you go on to that, Martin Winners posted Another free card is Design Spark Mechanical, entirely free, commercial or hobbyists.
Okay.
New version 6 was released this week, and for him, he finds it easier to use than Fusion 360.
So, can you repeat the name of that, please?
Of course, Design Spark Mechanical.
Design Spark.
Yes.
Okay. Mechanical.
Yeah, it's in the chat box, so it'll appear in the video for recording because we'll obviously produce the chat as part of the video as well.
Okay, that's interesting. I've never heard of it at all. And I would imagine a lot of people haven't.
Yeah. Well, thank you again, Martin, for that one.
Yeah, great. Brilliant.
Okay, back to you, James.
Okay, so I have drawn my milk churn, and as you can see, I'm just going to change my zoom because my zoom's got in the way. So we have our milk churn, our part. So if I want to create an STL file, what I do, I go to Utilities up here. And I just let Fusion catch up with itself. Okay, go on. I'm just having a bit of trouble with Zoom and Fusion getting in the way of each other.
Is it using your processing power?
I think so, yeah. Sorry, everybody, about this. It'll catch up with itself in a moment, I'm sure. Great, it's done it. Okay, so Utilities brings up a different set of icons, and on the left-hand side, you'll see Make. Make 3D print. That's the one you want. And as I said before, that brings up the little dialog with all your options. And as I said, Send to 3D print utility will be ticked. And the print utility you choose from this list here, but we don't have those. So you just want to create an STL file. So untick that. And the selection, what you want to do is to select the whole thing. And you select the whole thing by choosing the topmost item on the left-hand side here. Over here, we've got a list of the bodies, the sketches, the construction, but it's the milk churn, it's the whole thing you want to select. Okay, so it's now selected the whole part and it's drawn a light grey colour. And now the OK button is enabled. So I can press that and I can save that STL file to my working directory. Okay, so that is the first step. I've done my drawing and I've exported that as an STL file, a stereolithography file, which is the input for the next step in the process. So going back to my display, here we are, right.
James, just before you continue,
Mm-hmm.
Paul Stone has asked, do you need a particularly powerful PC for 3D software, special graphics card, memory, for example?
Not that I'm aware of. I'm pretty certain I don't have that. The laptop that I'm currently using is at least 10 years old. It was bought, well, no, that's probably not true. When did Windows 10 come out? Because I bought the laptop.
2009?
Was it?
No, Windows 10. No, Windows 10 will be later than 2017. 2016, 2017, probably Windows 10.
Okay.
Peter Reynolds might know.
This laptop was bought because Windows 10 had come out and I didn't trust it to begin with to put onto my existing laptop, which I was still using work-wise. So I bought a new laptop at that time. It's not a particularly high-spec one. So no, I don't think you need anything particularly special. Clearly, if you've got a slower computer or a limited graphics card, it's probably going to be slow to operate. It's being slow tonight, probably because it is also sharing the internet with Zoom.
Yeah.
So there's going to be a limited amount of capability because of that. Okay, so moving on from creating the STL file, that's your first step. Next thing is to take that STL file and get it made on your printer. The printer I have is an Elegoo Saturn, which you see a picture of here. It's quite a small device. It's only just over probably about a foot wide, not quite 2 feet tall, a very compact unit. And it has, the reason why I waited until the Saturn came out was that I wanted to be able to, at some point, I wanted to be able to 3D print an entire wagon in one go. And the Mars wasn't quite big enough. The Saturn is. The overall size of model it can make is large enough for an O-gauge wagon. So the next steps in your process is, from your STL file, you need to create the file that the printer uses, and it doesn't use STLs. Firstly, you need to put it into a program to add supports and then slice the model into slices. And it's those slices that get shone through the mask into the resin, causing the resin to harden in each individual layer. And the Elegoo Saturn comes with a program called ChituBox. Don't ask me why it's called ChituBox. I haven't the faintest idea. And that's the slicing program. So let's go and have a look at ChituBox, which is here. Okay. So what this program is showing you is an outline of the bed of the printer. So that area there represents the area of the printer tray, the tray that the resin goes into. And what you want to do is you want to add your parts onto that so that you can then slice it, and those slices then get made one at a time by the printer itself. So we go to File Open up here. We can go and pick a milk churn that we've just created. Boing! And there it is. Okay, so what do we do with this milk churn? Well, we can point at it and we can drag it around the bed and move it somewhere else if you want to. We'll leave it stuck in the middle for now. So that's our first step. So going back to our presentation. Okay, we've started with an empty project. We've opened the STL file and we have our milk churn sitting there in the middle of the bed. The next step we do is to rotate the model. It is normal to make all of your parts on the resin printer at a slight angle. And 30 degrees is a perfectly adequate angle. It depends on your part. It depends on a number of factors. You may find that it works better, or some parts work better at different angles than others. It's very much down to experience, but I will explain why you tilt it like this. The next step is to add supports to the model. And the supports hold the part that you're trying to make to what's called the build plate. And the build plate is the part of the machine that your model sticks to. Okay. So the parts on the printer are actually built from the bottom up. So the layers nearest to the tray are made first, and then it moves up further and further up into the model itself. So why rotate it? Well, the reason is, as you can see on the drawing on the right-hand side, if you look carefully, the middle here, you can see a darker area, which is the very bottom edge of that milk churn. And as you can see, that's pretty tiny. The other parts around are all parts of the support, which as yet don't quite meet the model. So the first support has been made, and the first part of the model is being made. And as each layer is produced, that layer sticks to the layer before it. So if you've got this kind of part, you can imagine that if you've got the next layer is slightly bigger, it will clearly overhang the existing part, but only by a very small amount. And it's stiff enough to hold its position. So each layer is then held by the previous layer and sticks itself to it. So this is an illustration of those parts getting bigger as you go along. So we saw the earlier one, and now the drawing on the left here, the part is grown a little, and the supports, you can see the supports are starting to build at an angle, so they meet the bottom of the milk churn. And then as it grows, more of the bottom of the milk churn is being produced. And once again, you can see that the supports are coming into play. They're holding those parts in place. And the further supports are coming into play as well. They are just starting to build towards where they are going to meet. And as you move further and further from the base plate, your milk churn is starting to build up nicely. And each layer is obviously it's a parallel cylinder. So each layer is an ellipse and is slightly off to one side compared to the layer before it. But because that overhang is very, very tiny, it's absolutely fine. So that will build up. Now, what happens if you don't rotate it? Well, you can try, and it may well work. So this is an example of our milk churn, which has not been rotated at all, and we've put some supports on the bottom. And you can imagine as that is built up, you've got your base, which is fixed to the build plate, and is usually bigger in area than the thing you're trying to make, because you can pretty much guarantee it'll stick, and its stickability is greater than the force required to pull the next layer off the build. And you can see, okay, so we've got our 5 supports coming up towards the first layer, and then bang, the first layer is a complete ring. And there's nothing holding the middle of that ring in place. Now, I could have put another support in, but even so, you've got a layer of hard resin, or hardish resin, that's 0.05 of a millimeter thick, the first layer that's made, and some significant gaps between the supported structure. So that is not going to work as well as the previous mechanism where you've tilted the model over, where it's built up much more gradually. There's no sudden parts that suddenly appear. And if you do have large layers that aren't supported properly, this is the kind of thing you get. And it's actually happened to me. I've had parts that I've made that have come out looking like, you know, you've thumbed through an old book, an old paperback, and all the layers are sitting there, but they're all separate.
James, could you use those as large model cheeses?
Yes, you could, couldn't you?
No, just a thought.
I'll have to put some cheeses in my shed.
Yes.
So I hope that's explained why you tilt the model over. So let's go back to our Box model for a moment and just see how we do that. So our model is selected and we go to the rotate option. Now, 3 axes you've got to rotate, the green, the blue and the red. And you can see the numbers here on the left-hand side. You can grab hold of one of these rings and you can move it yourself into position. So in some cases, it's quite nice to be able to see what you're doing with the model and which bits are going to be, how the thing is going to build, where you might need the support, whether you've got overhangs, etc., etc. Sometimes it's nice to be able to just play with this until it looks right. But sometimes it's just as easy to type a number into the box. I've typed 30 degrees into the Y, I've left the X and Z the same, and I fixed it at a 30-degree angle. It works for me. I've seen other parts made at 45 degrees. It's very much down to you, experience, and so on. Okay, so we've tilted that. The next thing to do is to add the supports. And to do that, we've got 2 tabs on the right-hand side over here. You've got the setup tab, which we're on at the moment, and then you've got the support tab over here. Okay. So the first thing it did was bounce my model off the bottom of the plate because it's got to have some space to build those supports. You've got a choice of types of support. As you can see, you've got light ones, medium ones that are that bit bigger, and heavy ones that are bigger still. Once again, it really comes down to experience. If you've got very tiny parts, light can be very good. Light might be good for some of your supports on a model. Medium's probably a good middle ground, worth going for. Okay, so choose the types of supports, and then you can, if you wish, press the All button, and it'll do everything for you. Which is fine, but actually, it's not done it very well. Let's have a look. We can zoom into the model. And with Box, if you use the right mouse button, you can rotate the whole thing. I hope you can see that.
Yeah.
Is that coming through, Ian?
Yeah.
Great. Okay. It's put a support here, but it hasn't put a support where I'd expect it to. On the overhang, you can see that I've got an overhang, and this bit that I'm pointing at right now has got nothing to hang off, nothing whatsoever. So the first bit of that gets produced won't be made properly. So as for its automatic supports, quite frankly, that's a load of rubbish. Okay, so let's remove the ones we don't like the look of. There's a minus delete option on the bottom here. I can click on that, I can press the delete key and it disappears. Click on that, delete it. Okay. The handles, quite frankly, don't need supporting, but the underside of the lid definitely does. So let's pop a support. Oh, no, wrong button. Let's press the add support button and add a support right on the edge, just like that. Okay, that's better. And I don't think 3 on the bottom is quite enough, so let's add an extra support there and another one over there. Much better. So you can see now that we've got a support right at the very bottom of the milk churn. We've got some extra supports, which are very useful to make sure that as you build up the model, that you've got sufficient resin holding, or cured resin holding that part to the bottom of the machine. and we've supported the overhang of the lid so the lid can build properly.
James,
Yes,
just going back to where you deleted the first rear support, has it left a part of it behind where it interfaces with the churn itself?
it does look like it, yes. I think that's an artifact of the
The
uh,
program,
of the program. It doesn't
right?
actually produce that in reality. But you're right, and there is a little tiny little, you can see it there,
Yeah,
a tiny little white bit, which I'm pretty certain if I select, I don't think I can, no, it's not really there.
right. Martin Wynn has also said for the milk churn, the bottom doesn't need to be flat for models. It can be gently conical and then only needs one support in the center or no support at all, easily filed flat for use on the layout.
Well, that's a very good point, Martin. Yes, you could do that. Yeah. Um, I mean, my only comment on that is, um, yeah, you could, you're then doing a manual step, which you don't need. Having said that, once you've taken the supports off this, there still will be little bits of resin, hardened resin sticking out where the supports were. You still need to file it. So actually, Martin's right. There isn't much of a difference. Okay, so we've got our milk churn, and we're happy that we've got enough supports on there that we've supported the overhang. The handles are small enough to support themselves when they're made. Great. Okay. Right. Other failures that I've had then going forward from supporting them.
James, sorry,
Yes.
just before you go, Paul Stone, another question. Why
Hmm.
does the opposite side of the lid not need a support?
Ah.
Or are we getting to that?
Aha. Right. Okay. Let's have a look at that. Let's have a look at that from the side, and let's look at that carefully. Okay. Now you can see what happens as you slice. You can see the black line here. That effectively is where the slice is going to happen. So you can see where I've got it at the moment, that the bit of the lid on the right hand side, just above the support, that there would have been nothing holding that joined to any other part of the plastic. But let's go up to the other part, the other side, where I'm now at the junction of the lid and the smaller diameter cylinder just before it. And the next bit, you can see that that part is being supported by the layer before. So that's one layer. Just go up a little tiny bit. And yes, there is a slight overhang there, but it's on a piece, there's a piece of plastic that's produced, which is sitting on the plastic below it. So that will make very nicely as it goes up there.
I suppose going back to Paul's observation as
That
well.
one won't.
Yeah, if going back to Paul's observation is if you hadn't rotated the milk churn to 30 degrees, where like you did with the bottom, where the first layer of the lid is, there's nothing supporting it all the way around the ring. It just
True,
becomes that first layer, and you got the edges have got nothing to hold them; they could sag.
true.
Yeah,
Yes. So if we can illustrate that. If we open the milk churn again, we can have a second milk churn,
yeah.
and then we can put some supports on that without rotating it. Okay. So we'll have 1, 2, 3, 4, 5 supports. There you go.
Making another rocket.
And you're absolutely right. That probably would work. Yeah, making another rocket. They do look like Space Lab rockets, actually, don't they?
Yeah.
So let's get that and it is perfectly feasible for that layer. As you say, that layer is then a diameter 1 millimeter bigger than the layer before it. And that might work. However, it might also not work. If that overhang was a little bit bigger, say it was 3mm, it would probably then end up as like book leaves, like I showed you before. So at this size, it probably would work, but why take the risk? You could find out experimentally whether it was okay or not. I haven't tried that. So overhangs are an issue. Anything that hangs below what it's ultimately attached to needs to be supported on its own, just like that. Sorry, a bit too rapid. So that kind of overhang, because it hangs below the join, needs to be supported. An overhang that's above what's it's sitting on is okay. I hope that makes sense.
Yeah.
Okay. Okay, so once you've got your model, I've found various issues that I've encountered. The build plate, yes, I do have a photograph later on. The build plate is, you need to be able to take it off to clean the build plate before you start. And also, once you've made things, you need to be able to take it off the machine and take the parts off it and then clean it afterwards. Sometimes the force that's required to suck a large area of hard resin off the film at the bottom of the tank, I've had the whole plate tilt over. So make sure you do the screws up tight. The supports can be too thin. I showed you that the supports, you've got light supports, medium supports, and heavy. I have had plenty where the supports have come out beautifully and I've got no model attached to them at all. Because they've simply broken off. So you've got to get it right, and it's extremely frustrating. And not enough supports. Trial and error and experience. You'll build that experience up over time. Okay, so we've gone through the process of adding the supports, and I've explained why you've got one on the lid rim. Once that was made, I had a very tiny little nipple of material once I broke that support away. That was a matter of a second or two to remove and smooth off. So it doesn't leave much behind. So you can have multiple objects on one plate. You can load further STL files, as I've just demonstrated with a second milk churn, add the support, and then you use clone to have more than one of a single object. But do the supports first, and I'll show you why. So very quickly, okay. Whoops. I'm still in adding support mode. Let's get rid of that.
That's an SRB for your rocket.
Yes. Right. So here we have our model, and we want to have 9 of them. So we go up to clone, and we click it, and we get another one, and another one, and another one, and another one. And you just keep going. There you are, 9 of them. Now, Chichibox is okay, but it's not bad. It's not particularly brilliant at putting them together. So you can very easily just grab hold of them and move them around the screen. And it's worth having a bit of a gap between each, because it makes it easier to get these off when they're made, if you've got a bit of space around them. So just move them around until you've got them in a nice orientation. And as I say, if you bring your model in first, one at a time, add the supports. When you clone, you get everything cloned. Quite a nice program. So that's what clone does for you. And that's an example of multiple churns and some barrels all set up on the same plate at the same time. Oops, sorry, didn't mean to do that. Let's click. The next step is to generate the slice file. So here what you're doing is taking what you've defined in terms of these are the models I want to make, these are the supports I want to have. I now need to produce the file that the resin printer will use. And that's the slicing step. And here my default layer height is a 20th of a millimeter, which I find absolutely brilliant, works really well. You can fiddle around with a lot of the parameters in terms of speeds, retract speeds, etc. I haven't found any need to change any of the defaults that came with the machine. When you've got the machine, this is the steps you take. So home the build plate to make sure that it is exactly the right distance from the screen, which is at the bottom of the machine. Tighten the plate screws tight, as I found. Raise the plate a suitable distance, pop the tank in, fill with your resin, select the file you've produced, and off you go. Put the lid on, go watch television. Even a small file will take the best part of an hour to produce. And one of my friends has just produced a very large model which took 23 hours. It takes some time. Okay, so the slicing process then, let's have a look at that. So we've got our 9 milk churns that we want to slice. And we simply press the slice button. And off it goes. You can see the little bar at the bottom of the screen, slicing your model. Right, it's done it, all done. And if we pull this down, we can see how the model is built. So let's go all the way down to the bottom, because the bottom is where we start. Okay, so we start with the base plates. They're the first bits that get made. And then as we go further up, so this is the order in which the parts actually get produced. However, as you will see in the photograph soon, it's upside down. So what you're looking at is, turn that upside down in your head, these are all hanging down from the build plate. And you can see the area here where you can see all the parts being, this is the slice, this is the amount of UV light that will come through the screen to actually harden the resin. And it's just these few dots. So these are our supports being made. And then we start getting some little moon sections as the milk churn is produced. And the milk churn grows and it grows until it starts to grow further, until eventually you can start to see the lid. Let's get up to where the lid is. Not there yet, not there yet. Yes, there you are. Right. The lid is just starting to be produced on top of the support until it grows into the material that's coming up from the body of the milk churn, until you get up to the top and it's complete. So that's what the slicer does. It's done the slicing and you save that file to your, save it to a USB stick, and that's what you transport to the machine. The machine uses that slicer file. It doesn't use the STL files. It Yeah, this is the next step afterwards. So that's what it looks like when it's on the build plate after a build. This was taken when I was making some barrels and also some tapered milk churns, a different style of milk churn. And I think you can see one of the effects of the resin not coming out of the barrels. The barrels were hollow, designed to be hollow, but clearly the resin has not escaped. I can't remember offhand whether I had the hole at the bottom or not. Probably, I probably had them the wrong way around, which is why they've ended up like that. It's fine. It's just a bit messy, that's all. So the final steps are to get your model off the build plate, knock the parts off the build plate and pop them into a vessel with IPA, that's isopropyl alcohol, which you don't need to use a vast quantity of, but some people use buckets of it. Drain the tank back into the resin bottle. The lovely thing about the resin is that you can reuse it. So the liquid resin can go straight back in its bottle after it's used. But do check for any solid matter that's in the tank. If you've left bits behind, then they don't go back into the bottle because they'll affect the next build. And take them off what's called the FET. It's I can't remember what it stands for. It's a thin film of plastic that sits between the tank, between the resin and the ultraviolet screen. And it's obviously there to stop the resin lying on the ultraviolet screen, which wouldn't do it any good at all. It's a clear film, it's very thin, it's very easy to damage it. And I clean the build plate with a paper towel and IPA. I clean the tank with the same. I wash all the parts in IPA. The next step should be to harden those parts. You can leave them out in the sun and there's sufficient UV light from the sunshine to harden the parts off. It will take 24 hours. Or you can buy a UV lamp, which I've got, and I pop the parts once they're clean, pop them onto a piece of wood, stick them in the garage, and turn the light on and then exit. Don't point the light at yourself or you'll end up with a nice tan. Now these are some very tiny 4mm parts that I made. I've showed you them earlier on. The lamps are available from Amazon and various other sources, and you will see that they come in all sorts of different ultraviolet wavelengths. 365 nanometers is often mentioned, but I found a paper that indicates that actually other frequencies penetrate into the plastic further than 365. I think my lamp is 405 and works absolutely fine. And you only need about 10 minutes. 10 minutes aside.
James?
Yes.
FEP is fluorinated ethylene propylene film. That's from Martin Wynn.
Thank you.
And Russell Burridge says, when handling the resin, do not do so in bright sunlight or harsh lighting, as it will start to cure without the UV source.
That's very true.
Yeah,
good point,
which
Russ.
is something to take into account if you're going to do some resin printing.
Yes. I mean, I do my resin printing in my workshop, which has no direct light that comes onto the machine. And generally speaking, I do it in the evening when it's dark.
Yeah.
So yes, the resin will obviously it's cured by UV light. So if it receives UV light, that will affect it. Ross may know this. You know the sort of red coloured plastic box that sits over the top, is that UV impervious?
Yeah. I personally, I would have thought so. That's why they're always coloured, aren't they? Tinted.
It is.
Yeah.
It does protect. It is impervious. I
Right.
mean,
UV filter.
I've got a Photon Mono X, which is a larger printer, and you can't operate it without the lid on.
Oh, really? That's interesting.
Yeah.
You can't operate it without the lid on.
Okay. So actually,
Sorry.
Yeah, sorry. The lid needs to be on for two reasons then. One is to prevent UV light, stray UV light coming in. But the second is because it reduces that stink, that smell.
Yeah, the smell's quite bad. Yeah. I've got a curing machine as well. You can buy a curing machine which it takes a vat which has about 2 litres of isopropyl in it, and a magnetic stirrer at the bottom, and you put your thing in there in a basket and it whizzes round. You can set a timer and it cleans it, and then once it's been done that, you can take it out, dry it, and then that comes off it, and you put a little turntable on the bottom, and you can put your item on the turntable, and that rotates round and does the ultraviolet curing.
Okay.
So it's actually the same make as your printer, James, but they're about £100 to do. You may get one cheaper if you look around, but
it's not bad.
So they're about £100.
Yeah. It's well worthwhile having the right equipment if you're doing a significant number of these.
If you're doing it a lot, yeah. Using a UV light and outside is a bit hit and miss. You have to watch it very carefully.
Yeah. Yeah, it's the UV light that I've got certainly discolors the parts.
Yeah.
But they get painted.
Yeah.
It's they kind of go a brown colour. And the colour gets darker if you leave the light on a lot longer. So you don't want to leave it on.
Sorry, Dave has said fluorescent lights contain UV? ?
Yeah, they do.
It depends upon the fluorescent light. It depends upon the tube.
Yeah, the older ones do.
The older ones do. The newer ones don't.
No.
But they can and they can't. It depends upon what the fluorescent tube is and what its design is. There's too many parameters of fluorescent tubes because there's so many different types that were on the market, and compared to ordinary incandescent bulbs or LEDs. Yeah. Andrew Taylor also asks, how important is room temperature?
Again, I can't be sure about that. My workshop is where I do my model making. It's where I'm sitting right now. It's usually anywhere between 18 degrees and 21 degrees. It's operating fine, but does anybody else have experience of using a resin printer in colder climes?
I mean, our house is normal. I've used it in the winter, but our house is usually at least 16 or 17.
But not outside in the winter, Peter.
No, not outside. I wouldn't be there in Arctic gear.
I couldn't get good results with cold resin. What I did is I heated up the build plate before I used it. So as it went down in the resin, it warmed the resin up.
Okay, interesting.
Yeah, that's a very good point, actually, Martin.
I suspect that you will need room temperature. I think.
I think it says on certainly the resin that I've got.
Yeah.
It gives you a temperature range. There's sort of like a sheet that comes with it.
Let me have a quick look. I've got a bottle here.
But while you look, Martin also mentioned for workshop lighting use an old type light bulb, which obviously if you've got any, keep them because they're in theory no longer manufactured by the main manufacturers, although you can still get them. Everything's going over to LED or even fluorescent CEL tubes.
That's right.
And Simon says disposable paper paint strainers work well for straining resin.
Yes, I mean, as part of the pack, they come with some filters, and I did use them to begin with, but I've not really found them useful since. You can kind of tell if the resin's hardened or if there are bits in it, which there shouldn't be. If all your models have come out, there shouldn't be any bits left behind. And I've been just pouring it straight back in the bottle, but you can pass it through a filter for sure.
And Simon also says room temperature does affect resin performance. Cold temperatures hinder the resin's performance.
Okay.
Room temperature is ideal. Cold garages don't work very well. It sounds like Simon's got experience of that.
It does, doesn't it?
Yeah.
My garage is cold. Yeah. The storage temperature on my resin is 15 to 25 degrees C. So that would have been a problem in the summer. This summer, because my house got up to about 29 inside.
Yeah, mine did one night.
Remember them?
But I remember those halcyon days of 29, 30
days?
degrees. Where have they gone?
Okay, moving on. Glue. Once you've made your parts, if you want to glue parts together, super glue works fine. Epoxy works fine. I haven't come across any solvents that will do anything to the resin at all. Again, be interesting to hear if anybody knows any different. Okay, precautions. Now that's interesting. I've actually put on here. Don't try and use it in a cold, damp place. Use gloves when you're likely to touch the resin. It does warn you about the resin that it's likely to. If you've got sensitive skin, it's really not good for you. Ventilate the area with the machine. If I'm doing 3D printing, I'll set it up. I'll then close the door, and if it's reasonable weather, I'll open a skylight to ventilate the place better. The resin can be well, not the hard bit, but the liquid can be reused as many times as you like. And IPA can also be reused. I generally leave, if I've used it for washing parts, I'll let it settle in the garage, and then I'll just reuse it and dip paper towel in it and use that as to wipe the surfaces. Perfectly okay. Right. Well, that brings me to a conclusion on that side of things.
Excellent. Ian McCormack has mentioned people use reptile heating mats inside the lids to raise temperatures to use in cooler places.
Okay.
Which is a pretty good idea. I like that.
That's a very nice idea. Yeah, I mean, it would be an advantage to use the garage because it removes the smell out of the house.
Yeah. I don't think the reptiles will like it though.
Yeah.
Could you use? Talking about filtering, could you use coffee grind filters, for example, for filtering the resin?
Probably, yeah. I mean, I've got one of the filters.
Obviously, I know that they work better because the water is hot that you're filtering. But
that's the sort of thing that came with the machine. So you've got drops in the top of the bottle. It's got a fine, very, very fine mesh here. Works very nicely, but it's just got another piece of sticky rubbish to throw away. If
it's very, very fine mesh, you're putting old nylons. Not that I wear any. I just want to say that. I want to put it out there.
Either does my wife.
I'm glad you clarified that, Ian.
Thank you. Does anybody else have any questions? Does anybody want to come on to a live chat, unmute themselves to ask James any questions?
Yeah, Russ here. Just a couple of points. I've used an earlier Elegoo machine, a Mars, until about a year ago. I just haven't got the time at the minute. But what I did find is I've also bought the little activated charcoal rechargeable filter. They're like little fans that suck in the fumes.
Oh,
these are small enough to sit inside the casing when you're actually doing the printing.
Wow.
and they last for hours and hours. And you get 2 in a pack, I think. But I think some of the later machines and other manufacturers' models actually come with them built in, and that'll take the smell away when you're printing. It won't, of course, take the smell away whilst you're handling the resin or washing things afterwards and stuff like that. But they do certainly help. They got a problem. I was setting up my my Elegoo Mars on the shelf in the bathroom. Not that you're supposed to have mains electricity in the bathroom, but it wasn't anywhere near the basin or the shower. But anyway, it seemed to work all right.
That's yeah, I'd like to know about that. Let me know about that charcoal filter. That sounds very interesting. I quite fancy getting one of those.
Well, if I can dig one out, I'll bring it over tomorrow.
All right, cool. Yeah, nice one. Thank you.
Oh, that's nice.
Yeah.
Sorry, Ian, I don't live
No, it's
very
all
near
right.
you.
It's like, why couldn't you have had it tonight? You could have held it up and shown us all.
Oh well, it's out in the garage
And it's cold.
where it's cold. Yeah.
Yeah.
Okay.
Are there any more questions for anybody at all? I mean, one thing that I found interesting in all that was, because even though I understand 3D printing technology, whether it be FDM or stereolithography, is I wasn't completely aware that it was done downside up. And the build plate was at the top and it came down from the build plate. I wasn't really aware it was working like that, So that was good that you covered that in the brief, and showed the examples, and also showed the examples of what can go wrong whereby you've got a hollow object and the resin's still in it. I mean, they did look like very nice little shot glasses with something to imbibe yourself with. But that was good to show that, James. Thank you.
Okay, good. That was those barrels were a mistake. I clearly had them upside down. I should have put them the other way around.
Well, no, they were the right way around, but they're built upside down. Yeah, obviously.
Well,
yeah,
exactly. And again, I've not made parts that were hollow before, and I thought, well, a barrel, I could put the barrel either flat bit down and then it'll be open top, or I could turn it the other way around. Then it's a full, a barrel with the top on it. So it's kind of multi-purpose. And yes, you're right. I didn't consider I had it the wrong way around when I was putting it on the build plate. And you learn these lessons.
Yeah. Well, I say it's one of those things to consider because it does work upside down. So it's counterintuitive, isn't it, to what you expect it to do?
Yes. But clearly, from a human brain point of view, if you try to have the plate upside down, your brain wouldn't work properly.
Yeah.
It's like, oh God, how's this working? Hang on a minute. That doesn't look right.
Yeah, you're right. Ian McCormack again has said a charcoal filter from Elegoo are about £15 for a pair from Amazon. Ian Major has asked, what do you use for filler on your printed roof joints?
Oh, right. Yes, filler. I have got. There we are. Perfect plastic putty. That's what I used.
Yeah, brilliant. There you go, Ian.
That's the stuff. It's amazing. Everything's to hand in this workshop.
Yeah, well, the drawers followed you out as well.
Yes. Just close it.
Paul Rowe asks, what about drilling and sanding? Do you need face protection or, probably face mask or anything? If you're sanding, drilling it.
You should do, yes. Yes.
Definitely for sanding because the dust is very fine.
Yes. And that, you will do. Again, it depends on how much you're doing, etc. You can judge that yourself, but not breathing the stuff in is well worthwhile. I mean, I'm building it's the same of any sort of resin casting. I'm building a bullied Battle of Britain at the moment, and it says there if you sand the body, which is a large resin casting, to use face protection.
Yeah, right.
So I would advise that. Yes.
Yeah, thanks for that. Paul Rose says thank you. I was going to ask something as well. I can't remember what it was now. Asking these other questions. Are the parts soft or brittle? Asked Paul again.
It depends on the resin. Depends on the resin.
Yeah.
I've been making parts, as you saw, those little tiny parts for the weed killing train, and they were made out of a clear resin, and it's very brittle. The pigment-free stuff. The coloured resins appear not to be quite as brittle.
Yeah. So
very variable. If you do want something that's less brittle, you can choose a resin that suits. They all have specifications.
Yeah, and I know that personally from just chatting with other guys that are doing 3D printing, having put the feelers out for some stuff myself that needs doing. There has been mention of year on, the resins are getting better and better.
They are.
In terms of what is available, the technology, and also we're now getting some quite tough resins that when they're when you've used it and produced a part, they actually are very, very tough as a material.
Yeah. Yeah.
I'd also read, this is what I was going to ask actually, I'd also seen somewhere that somebody said once something's been printed and it's been cured, make sure you paint it quickly because they can go brittle. And I thought, well, if they're out in the UV, surely just getting harder and harder.
Yeah, I don't think that's
the
case necessarily.
No, I don't.
They get more brittle.
No.
But Russ, again, can I just make a point that there's quite a few forums on Facebook for all these different manufacturers, Elegoo and different manufacturers' printers, and including the Saturn and Mars and other things, Photon. But also what you get on those forums, a lot of it is US centric, but you'll get information about different resins that they're using and the temperatures they're using and the settings they use for layers, etc., etc. And it's quite a good source of information because they've done a lot of the hard work in finding out what works and what doesn't work. And one of the good resins for if you want a tough resin is a thing called Soraya Tech, but I think you have to import it and have it sent from the States. And as you know, any shipping from the States costs you probably twice as much as the product. So, unless you can get hold of it from Amazon in the UK, it probably isn't cost effective. But there we are, just a thought.
That's great. Thanks, Russ.
That's what I use, Soraya Tech resin. You can get it from Amazon. It costs a little bit more than the others, but it is.
Oh, you can. That's good.
It is good stuff. But I've seen it. There's certainly for my printer, the Photon. There is a spreadsheet that you can get from the manufacturer, which has got all these all the settings for. It's like 2 or 3 pages really of resins that people have used, and they've sent in the settings. So it gives you all the exposure settings and everything else like that for the resin that you use. And all you have to do is put it into the your slicer when you create the file, and it does it all for you. You don't have to worry about it. It embeds the exposure and everything into the code when it prints the item according to what resin you use. So you specify the resin in the slicer, and then it does it from that.
Kerry Viney has said, I have a reusable filter which I wash in, I think he means meths, to clean the resin.
Okay. Now that's an interesting thing. Do people find meths better at cleaning than IPA or not?
I don't know. I just use IPA.
That's what was recommended. I hadn't thought about it.
It was what was recommended to me, and it does clean everything up nicely. But
I suppose one advantage is meths isn't hygroscopic, is it? Because IPA absorbs moisture.
Okay.
Meths doesn't.
You have to.
Yes.
Sorry. Yes. Go ahead, Ian.
Yeah, I was going to say a mate of mine, Dave Lowe, is allergic to IPA.
Oh.
He goes bright red and skin falls off and stuff.
Yeah.
Don't go there. But meths is what he uses, absolutely fine. And I used it during the lockdown when I couldn't get IPA, and it didn't have any. In fact, I think it was better actually.
Yeah.
I was wondering,
even worse than IPA.
I don't know about your experience with IPA, but I find that everything's still sticky after I've washed it.
Not,
my
not if you
side, it's
give it another
okay.
wash
Oh,
in clean
yes.
stuff.
Give it another wash. I have tried
Yeah.
that. I've
No,
tried
but
multiple
in
washes.
brand new clean stuff, and that should
Maybe
go.
try meths.
The,
Try a bit of
instruc-
meths.
I will.
the instructions with the resin do say it has to be 99% lab grade IPA.
Yeah, it has to be
Ordinary
99%.
industrial IPA doesn't work so well.
No,
Right.
it's got to be 99%.
I wonder what I've got.
I use methylated spirits because it's
Just had that
much
delivered,
cheaper than
so-
IPA.
Yeah, that's all right.
100% there.
Thanks, Kerry. Yeah, did you hear that?
Yeah.
I'm not
James?
sure. Yes, I use methylated spirits because it's certainly much cheaper than IPA. But what I've got in my hand for James, this is a filter unit, which I bought from AliExpress. And it
Can
costs
you,
me about $3.
Yeah.
So you look down 50 and you can wash it out. And after I've used it, it sits in a jar with methylated spirits.
Okay.
Just a species after I clean it out.
Let's have a look at that, Kerry. Can you highlight that, please, Ian?
Where's Kerry gone on the list?
And that's the flexible filter.
Oh,
Funnel.
wow. Okay.
And it comes as a kit.
Nice.
Yeah, that's what I
James,
use.
James, I will send you a URL.
Oh, lovely. Thank you, Kerry. I'd appreciate
Or
it.
Kerry, just post. Can you just type the URL in the chat box? If
Well,
not,
at the moment, no, I don't know. I have to go and find it.
okay.
Okay.
No, all right. Okay. No. Right. Okay. No worries. Yeah. Yeah. If you can send it to either James or
I'll send it to that email. Now, while I'm on
Yes.
here, was I supposed to receive the video before this Zoom meeting?
James didn't make one.
No, James
Okay.
didn't make one.
James didn't make one.
That's all right. I'm waiting for it and waiting for it in expectation. But it
Well, I
didn't.
think,
And
one of
mind
the
you, I
prob-
started to think that being on the other side of the earth, that would be the difference.
well,
And
it
whilst
does.
I've still got here on temperatures, you guys are talking temperatures.
Yeah.
Of course, I don't have that problem. It's going to be about 35 here today. So the
Nice.
fans are already on here at 6 o'clock in the morning. But what I wanted to say about that is that I've seen on YouTube where there are guys that have actually had a heating unit, not only the reptile mat, which I use in a plastic container to keep my PLA plastic dry, but I noticed they've used that and made a unit and extracted and put in hot air to keep the resin at a reasonable temperature. As you say, cold resin doesn't work too well. And I also want to make the point, which I did, I think, on the forum, is that I always drain my resin back out of the vat if I'm not going to use it for a while.
Absolutely.
I strain it again through here into a separate bottle.
Uh-huh.
And when I've used that, and I can use that bottle later on. But the question that somebody asked was, can you leave your resin in the vat for a while? Well, it will sink down. Sure, you can scrape it, and there are various means to, but invariably you will scrape the FEP. So you put marks on the FEP. So if you drain it out when you're not going to use it, put it back in the bottle and you can keep using it again. Yeah.
Absolutely.
Okay, so I'll unmute myself now, but I'll just get that URL to you guys.
No, that's great. Thank you, Kerry.
And
No,
if you buy from AliExpress, you can use your PayPal.
okay.
A lot of people are concerned about buying from that country in terms of credit card security. But I've never had that problem.
Okay.
I've had a separate credit card for many years with a very minimal amount, but I've never had that. But now they have PayPal. But for me, I've got to get a lot of stuff. And whilst you guys can get it in the UK, it ultimately comes from that country in Europe.
Of course. Yeah.
Brilliant. Thank you, Kerry. Appreciate it.
Kerry makes Kerry makes a very good point, and that is that I certainly clean all the parts of my machine thoroughly after I've I've made some parts. I've never left the resin in the tank.
No.
Always, because the first thing that I do is once a build is complete, the build plate will rise to the top of the machine, and you undo the nut, take it off. I put it into a plastic box. That goes out into the garage for cleaning. I then take the tank, undo the screws, and I pour the liquid back into the bottle. And then I put that on a tray at a slight angle so that the resin will work its way down to just one side of the tank. And I take that into the garage and then I clean everything.
Yeah,
And then once it's clean, it comes back on the machine. I put the parts back on the machine in the right place. Lid goes back on, job done. And it's the same as if you're using a spray gun. I don't know about you, but if I spray using a spray gun and airbrush, I take the airbrush apart, I clean all the parts thoroughly, and I put it all back together again, and it goes back in the drawer. And then I know that it's absolutely ready for the next time I want to use it. And it might not be for a month.
That's funny because I leave stuff in the tank for months on end. I just reuse it as I need it.
Do you really?
And top it up when it gets too low.
Wow.
I mean, it works fine. All I do is put a piece of kitchen aluminium film over it to keep the dust and any stray UV out when it's not in use.
Right.
Of course, it's important that you check that each printed completely, because if there's any part missing, it's going to be in the tank.
Yeah.
But so in that case, you then have to filter it out and clean it and so on. But providing you've got a perfect print, I don't see any reason why you should empty the tank at all. You need to stir it up before you use it the next time because it can settle out.
It will settle out.
Yeah, I use an expired credit card as a stirrer, which works fine and scrapes the FEP at the same time and just reuse it. So
do you rehome the machine before every print?
No, I do it occasionally. I've actually got two build plates so that I can start the next one straight away while I go away and wash the first one.
Okay.
And so you have to be a bit careful to make sure they're both set up to work at the same home setting.
Right.
But once I've done that, I haven't checked the home for at least 3 months. I just go in there, plug the USB in, and wipe over the build plate with some IPA, and switch it on, and that's it.
Okay. What machine have you got, Martin?
Elegoo Mars 2 Pro.
Okay.
Very
interesting.
The resin I use is called the ABS light resin, which is slightly toughened for making the track chairs, you know.
Okay.
And that's really quite strong, not brittle at all. Whether it would get brittle if it had more UV left on a windowsill, I don't know.
Okay.
But it will be painted as part of the track anyway.
Yeah.
But it's so much easier just to leave it in the tank. So much cleaner.
Cover it with foil. So
I'll cover it with foil, put the lid on, and
that's
it until I next need it, which might be several weeks.
Very interesting. Okay.
I've probably done that 2 or 3 times. I probably only cleaned the tank out completely about twice since I've had the machine.
Wow.
But you have to be sure.
I do the same. I do exactly the same. I cover my printer with bits of paper towel, on the roll, and I leave the resin in. I suppose I'm printing 2 or 3 times a week, so no problems at all. As Martin says, I just use that yellow plastic spatula thing, and I just agitate it a bit and get any solidification out, so it's all mixed up again. If it is really badly settled, then I'll pour it out into the bottle, give it a good shake, and shove it back in again. But that's all I do.
Amazing.
Yeah. No. So
the important thing is to make sure you've designed the print so it does all print 100% result. Because obviously, if you take the part out and half of it's missing, the other half's going to be stuck somewhere down in the resin.
Well, exactly. You've got a flat piece sat on the FEP on the plastic, and that needs to come off.
Again, there's one of those tank clean in the menu now. You just run that for 10 seconds and just peel off the bottom layer off the FEP, and it all comes off. So, again, it pulls up all the muck and anything else that's on there, and uses a time. And I only do it for 10 seconds, but it's enough to get everything off if you have had a mistake.
James, going back to the discussion about cleaning off afterwards, John Walker said, after washing in the wash and cure, I rinse with clean IPA through an old airbrush, and that removes sticky residue. And then I blow air only to dry it before post-curing.
Okay, interesting.
And Simon has said, I leave resin in the tank, but use a cover which was printed using an FDM printer to fit the tank from a design on Thingiverse.
Oh, brilliant. That's really clever.
Yeah.
Yeah, Thingiverse is good. People don't often pick up on Thingiverse, but Thingiverse is quite good.
It is very good. There's quite a lot of railway stuff on there.
Yeah, there is. Yeah.
Any Lancashire and Yorkshire stuff? No.
I have to look, but
I haven't noticed, mate.
That's where our advertisement hoardings came from.
Yeah.
Yeah.
Okay.
And John Walker again says, I leave resin in the vat on the printer, protected only by a cover. So seems like quite a few are leaving the resin in the tank at the bottom.
Fair enough. I'd be.
I mean, if it works for you, and you don't have any issues, then fair enough. Why change? But it's one of these things where different people are using different techniques. Or
well, that's part of what these sessions are all about.
Yeah.
It's not just me telling you what I've learned, but you telling me what you've learned.
Yeah.
That's the great thing about this community. We all learn from each other. We all write articles for the Gazette, and we all have in some different ways of doing things, and that's healthy. Because
well, things to try, aren't they? Yeah.
I think what is good with this, especially the 3D print side, is because it's relatively, in strict terms, a new technique and a new tool to our workshop. It's everyone's learning new things and different things, and this is where we're getting this exchange of ideas and information and experience, which is great.
One tip I've got is the instructions say that you must shake up the resin well before you use it. Well, if you've got a half-used bottle, you shake it up like mad, and when you pour it out, it's all frothy.
Yeah.
No good. But the trick I use is to chuck glass marbles into the bottle until it comes up brim full, put the cap on and shake it up, and there's no air in there then to make it frothy.
Fair enough.
Yeah,
that happened to me with a new bottle of clear resin. I gave that a good shake because it had been sat on my shelf for the best part of a year, and it went in the tank very frothy. And I thought, this is never going to work. But actually, the action of the build plate squashing down into the resin seemed to.
It does push most of the air out.
It did seem to remove the bubbles. I didn't have a problem.
Well, I found it a bit, when it was frothy, I got little sort of pop marks on the parts.
Okay, no, I didn't.
But if you put marbles in the bottle so that there's no air and then shake it up, it's not frothy.
Yep. Amazing.
Just don't let them fall in the tank and not notice, because they won't do any good.
They won't do anything at all. No, absolutely not. No.
James and anybody else. Simon has asked. John Walker has asked, can you recommend a clear resin?
Well, the stuff I've got here is this. It's Zortrax.
Photopolymer
free.
Yeah.
And it comes out completely clear. However, the UV light did turn it a little bit a slightly brown colour. I haven't got any here. I did have a parts, and I don't know what I've done with it. That shows it going, because I was trying to produce some lamps for again a 4mm layout that my friends wanted.
Right. And Simon has also said the Gauge 1 people, Gauge 1 group, I have a very good 3D printing forum group available to everyone with Zoom sessions every week.
Wow. Very good.
So that might be worth looking at for some of you.
Okay. Yeah.
So are all done and done? Do we think?
Yep.
Right. So let me see. I need to do a screen share. So James, thank you for what I think was an extremely interesting and well presented session. I really enjoyed it, and I learned quite a lot. And I'm sure a lot of other people benefited from your input, and also from the other contributors that have managed to put their experiences forward as well for everyone. So thank you so much. It was a really good start to our year of evening with sessions. I appreciate it.
Well, thank you. Thank you very much, everybody, for
thank you.
listening.
Okay,
Thank you.
so just before we go, can everyone see this that I've just put up? So Jackie Neeshaw said to me, "Oh, Ian, remind everyone 6 weeks to Kettering." So 6 weeks to Kettering, everybody. So our current 3 shows for the year: Kettering, Saturday, the 4th of March. We've got the summer show at Barnsley on Saturday, the 3rd of June, at the new venue. Gildex at Stafford on the 2nd and 3rd of September. And of course, we've also got the new show at Kempton Park. And for the life of me, the date has slipped right out of my mind. So between March and June, we've got the new Southern show at Kempton Racecourse. The reason Jackie and some of the other guys from the events team aren't here tonight is because they've been down there today looking at the venue and having some meetings with the staff down there. So they were getting back too late. I think Tony Kell wasn't getting back until about 8 o'clock. So that's why I'm hosting as well. And then, of course, next month, you've got this idiot doing Templot Part 3.
Oh, no.
Why do I let myself? I really don't know. No, but no doubt Martin will be there to support me, won't you, Martin?
Well,
So
I'll be here whether it'll be a support or not.
oh, please. So
It's that
tickets
phrase, you
for,
must be joking.
yes, tickets for the evening with myself, Mr. Ian Allen, for the 26th of February. They'll go on sale or be available to order from midnight tonight. So that's all I'm going to say on that.
Great stuff. Well done.
Stop share, and view gallery, and you're on spotlight. So I'd just like to thank everybody for this evening who came along to join from all parts of the globe. I hope you had a very interesting and educational session. We had a peak of 43 members, and by 9 o'clock we still had 42 members.
We had 44.
Was it 44? Thanks, Peter.
Yeah.
Oh yeah. So we only lost one person by 9 o'clock, and normally we start to lose people after 9 because they'd go and do other things. But I think you all agree, an extremely worthwhile session from James and the other guys that have contributed their experience as well. So thank you very much, and just like to wish everybody a very good night, and hopefully see you all soon.
Cheers, Ian. Thank you.
I've got to get up at 4
Thanks,
a.m.
everyone.
So I've got to go.
Cheers. Thanks, Peter. Thanks,
Bye.
everybody.
Bye, James. Bye, everyone.
Bye.